Hello, in this video I wanted to go over this ticket I created inside the Chromium issue tracker that talks about encrypting IndexedDB and why I think this is helpful for not just the extension that we're creating as a company, but in general for a lot of extensions out there. So first I'm going to introduce our extension, which is called Yoroi. I have it downloaded right here. And basically how it works is that you can click on this tab up here and it opens the extension. Okay, and this extension manages a certain blockchain called Cardano. So if you're not familiar with blockchain technology, I'm gonna give a very brief discussion about it in this video, explanation of it in this video. But Cardano is one blockchain. Another one you might have heard of is Bitcoin, Ethereum. These are all different blockchains, different networks, but they all work in somewhat similar ways. So what does this extension actually do? It shows you your balance on the blockchain. Okay, so here I have 0.68, which is worth maybe 1 cent just for demonstration purposes. And the important thing I want to emphasize is that this has real financial value. Obviously, some people think, blockchain should be worth zero or whatever. And even if you think that, the reality is that this has financial value to somebody, which makes it worth protecting, right? So we want to protect somebody's financial assets. Now, the problem, as you saw, is if I open the extension, I get access to the balance right away. So if anybody has access to my computer, they could easily open up the extension and see how much money I have, right? So we take some precautions in this, and that you can send money to people through our extension, right? So I could send my 1 cent to somebody else, but to do that, I would have to enter a password, right? So let me just show you an example. So let me send 0.1 here. It's going to ask for a spending password. Now, the reason we ask for a spending password is because the way that cryptocurrency wallets work is that every wallet you see here, so you have a test wallet, every wallet is a private key and a public key. Okay, so if I open up my storage over here, application, IndexedDB, you can see I have a table here called key, and it contains 2 keys, right? One of which is my private key, which is up here, which is encrypted, and the bottom one is my public key right here, which is not encrypted. Okay, so this is encrypted with your spending password. So you can see here, if I type the wrong spending password, I'll get an error saying that I had the incorrect password because it'll fail to decrypt. Okay. So this is nice because it means that even if somebody hijacks my computer, they can't easily steal money from me, right? But they can still see my financial history, right? They can see how much ADA I have, and they can see all the transactions I've made over time. And so we would like to also encrypt this information, not from a loss of money perspective, but just from a privacy perspective, right? So you might say, well, okay, how would these transactions work? How would we encrypt just the user's transactions? Well, you can see here the way it works is that whenever you send people funds on a blockchain, there's a receiver, or sender and a receiver. So you can see a from address to address. So these addresses here, they're just hexadecimal strings, or in this case, it's base 58, I think. Not hexadecimal, but so these are generated from the user's public key. So the public key can generate addresses, and you can see here I can generate as many addresses as I want. And all of these are generated from the public key as a seed. Okay, so you take the public key plus some index, so this will be public key plus index 0 will give you this address, public key plus index 1 will give you this address. So the important thing is that these are one-way functions. So if I accidentally leak this address, that it belongs to me, you can't find my public key. But if you leak the public key, the person can track not only all your addresses now, but all your addresses in the future. All right, so we really want to protect this public key, but it's also useful to protect these addresses. So that's not too bad, right? We can encrypt this public key also with this password if we really want to, which has some user experience problems with it, but it's possible. Right, we could also encrypt these addresses, and whenever the user opens the extension, they have to type in a password, and it will decrypt these addresses. Right, this is all doable with some UX tweaks. But how far can we really take this with just UX tweaks, right? So we can easily encrypt these, and why is because they're strings, right? We can just do the same thing we did here, where we encrypt this specific column or this big row in our table, right? And the user provides a password to decrypt. This gets a bit more complicated with transactions, right? So the way transactions work on a blockchain is that transactions are processed in discrete steps. So if I open some Explorer, which shows you the blockchain itself, you can see here we have a concept of a block, or it's called a slot. And this happens in discrete steps. So in this blockchain, it's about every 20 seconds, there'll be a new block that comes in, okay? And each block contains a set of transactions, right? This one contains 2 transactions, one that sends some amount of money and the other one that sends a different amount of money, okay? So every 20 seconds, there's a discrete step that processes a bunch of transactions, in this case 2, right? And the way you send money is by referencing a transaction where you receive the money, right? So for example, if I want to spend this 0.6 ADA, the way it's represented is that I say, okay, here is where I received money, and this is where I want to send money. So that's the kind of the internal representation of the data structure, which means that for this wallet software to be able to process this, oops, let me open this right here. You have a set of places where you received money from, which contains some transaction ID and some hash and some other information, and where you want to send money to, which contains an amount and so on. And that means that we also have to keep track of these blocks, right? So we have a table right here that keeps track of blocks that are relevant to your wallet. So you can see here I received 2 transactions, and probably these were created in 2 different blocks. And so I have 2 blocks in my database, which contains some number, right? So for example, this block right here, you could say it's block 4787, for example. So these blocks are numbered, they have a specific number associated to them. And when I send money, it's okay, I received money in this block over here, and I want to send this money I received, okay? So that means that not only do we need to encrypt these strings, but information such as this block number, which is not a string, it's just a number, also is very important, because if somebody knows that I received money in block 4787, and they know that my index for the address that belongs to me is the second address in the receivers, then just based off these integers, right, which is a block number and an index inside a transaction, they'd be able to figure out my address, right, which leaks privacy. So in IndexedDB, we don't have an encryption feature, right, and we can encrypt strings not to without too much extra work, like I showed you. But it gets harder to encrypt integers, right? Because of the reasons I mentioned in this ticket. And also it gets harder if you encrypt data to do joint queries, right? So you can imagine when we send a transaction, we have to join many tables, right? So we look at all your keys, and then we join them with some transaction information, then we join them with some blocks. And so we join all these tables together, and it's really hard to do this in a way that makes logical sense if you've encrypted a bunch of data ad hoc, right? Because then you can't just join something, you have to read the whole table, decrypt the whole table, and then to be able to index correctly inside the tables. So this is kind of the problem that we have, and obviously we're not the only extension that works like this. We're not the only browser extension that interfaces with the blockchain. So for example, this extension right here called MetaMask has over 1 million monthly active users, and so obviously you can tell from these download counts that the blockchain ecosystem represents a non-trivial amount of users, because I think MetaMask is one of the top extensions in Chrome in the productivity section. So if you go to top extensions, it'll show up in the list. So there's a non-trivial amount of users that have these extensions downloaded, all which have kind of this privacy problem where if somebody accesses your computer, they could look at the information and derive some of your financial information from it, which we would like to avoid. Okay, so what I would like is some way to basically encrypt the database as a whole. So basically, this entire IndexedDB would be encrypted entirely. And when the extension opens, you'd ask a password, and this password would decrypt the entire IndexedDB. And so if you encrypt the entire database, then you don't have this problem anymore with this weird join behavior or the difficulties encrypting integers, because the entire database would be encrypted as one giant object. And having this behavior will make it much easier for us to develop, and also much safer, because you can imagine if we take this approach where we encrypt columns one by one and we have all this weird join logic, it makes it much harder for engineers to come afterwards who are not as familiar with the code base to accidentally make a mistake and they don't encrypt the field even though they should have, and that means you leak a certain amount of information, and an adversary could come in and piece this information together to figure out your transaction history. And that's really what we're trying to avoid. Hopefully this is a good introduction of what we're trying to do and the privacy problems involved. If you have any questions, please ask the question in this ticket here on the Chromium issue tracker. Thank you.